The electromagnetic spectrum. We will learn in this video about the electromagnetic spectrum and its main characteristics. The electromagnetic spectrum, EM spectrum, E refers to electro and M refers to magnetic. It's a continuous spectrum of waves which includes the visible spectrum, as you can see here in the figure. The visible part of the electromagnetic spectrum, the one that you can see with your eye. When light hits a prism, it's divided into the basic colors, which are the rainbow colors. Each color represents a wave of specific wavelength and frequency. We can recognize how the colors are stick together and they're not separated from each other. That's why the EM spectrum is a continuous spectrum of waves. This figure shows the electromagnetic spectrum and its different parts, where one of them is the visible light, as you can see here. All the waves have the following properties. First, they all transfer energy only, not matter. Second, they are all transverse waves, as you can see in the graph, where electromagnetic waves are a combination of electric and magnetic fields that propagate in phase and perpendicular to each other, plus their variation is perpendicular to the direction of propagation of the wave. Third, they all travel at the speed of light in vacuum, which is 300 million meters per second, or we can say 3 times 10 power 8 meters per second. And the last common characteristic between all electromagnetic waves is that, fourth, they can all be reflected, refracted, and diffracted. Although the spectrum is continuous, but the waves are of different wavelengths and have different effects, so it's easier to study them if we divide them into groups. Each group of waves have different properties because they have different frequencies and wavelengths. We'll see now the different groups. These are the types of electromagnetic waves, and then here's their typical frequency in hertz, i.e. the range of frequency each type of wave can propagate in, and their wavelength in meters because each type has different wavelengths than the other, as we said. Here are the sources of each electromagnetic wave specified and their detectors, as well as some of their uses, so we can understand the idea more. So, the radio waves have minimum values of frequency and the maximum values of wavelength, while gamma rays have the maximum values of frequency and the minimum values of wavelength. We can recognize that the values of frequencies for the different types of waves are in sequence, as the radio waves propagate in a range of frequency of 10 to the power 5 to 10 to the power 10, and microwaves propagate with a range value of frequency between 10 to the power 10 and 10 to the power 11, and so on. Infrared 10 to the power 11 to 10 to the power 14. The same is applied for the wavelength. Each type propagates with a range value of wavelength, as you can see, in sequence between each type and another. And that's why they're called continuous spectrum. We will discuss each type of electromagnetic waves that are tabulated here in detail, along with their sources, detectors, and uses in further videos.